P. 小工 aboard. Your learning journey starts now. Right. The million-dollar question versus NP. We know what it is. We know why it matters. The consensus leans towards P not equal to NP, but that's just a gut feeling, a lack of proof. Standard algorithms are hitting a wall. So, what if the answer isn't in faster code, but in thinking differently? So, we've thrown everything at NP problems, brute force, too slow. Fancy heuristics, and branch and bound. They work sometimes, but worst case, still exponential. Approximations get you close, but not always right. Special cases yield to clever tricks, but the general problem remains stubbornly hard. Even the AKS primality test showed us that perceived difficulty can be deceiving yet factoring large numbers. Still a beast, after decades, the traditional toolkit feels inadequate. It makes you wonder, are we just looking in the wrong computational closet? Maybe the Turing machine model itself is missing a key dimension of intelligence. Enter DIKWP. You know the classic DIKW pyramid: data, information, knowledge, wisdom, solid stuff. But it misses the why, the driving force. So, we add purpose, making it dictal. Think of it as layers of understanding. Data is raw input, information gives it context. Knowledge is actionable rules. Wisdom is judgment, knowing when and why to act, and intent. That's the North Star, guiding the whole process. Crucially, these layers aren't separate steps. They interact, feedback, creating a richer, goal-directed cognitive loop. This isn't just about data processing, it's about meaning-making. Let's make this concrete. How do humans solve seemingly complex problems without brute forcing them? Take guessing someone's age from hints. You get fragmented data, ends in 1, retiring soon. Your brain immediately starts converting this into information age ranges, cultural cues. Then, knowledge kicks in comparing yourself, using reference points like your parents-in-law. Wisdom guides the strategy, avoiding direct questions, using analogies. And the underlying intent, I need an approximate age. See how quickly you converge on a likely answer. You didn't list every possible age and check. You used semantics, context, experience. You compressed the search space based on meaning. This intuitive leap, this semantic pruning, is the magic we want to capture. So, can we build a machine that does this? A semantic compression solver. Imagine a system built on the DKWP framework. First, it needs smart semantic representation, turning raw data into structured meaning. Then, a robust knowledge base packed with rules, patterns, theorems, learned heuristics. Crucially, goal-driven control, the intent layer, dictates the overall strategy. Is it looking for any solution or verifying a property? This drives multi-level reasoning, constantly cycling through data, info, knowledge, wisdom, refining hypotheses. Guessing isn't random. It's guided by semantic analysis. And the verification is efficient. The core idea is semantic compression, using meaning to shrink the problem's complexity before diving into computation. It's less about pure symbol crunching, more about intelligent interpretation. Does this mean we've cracked P equals NP? Not quite. But it opens exciting possibilities. Perhaps we won't achieve strict P equals NP, but we could enter an optiland where many practical NP problems become tractable, leveraging AI and semantics. Could this inspire new proof techniques? Maybe. But there are hurdles. It relies heavily on good knowledge. And for truly pathological worst-case instances, it might still hit exponential walls. Formalizing this within standard complexity theory is non-trivial. However, the potential is immense. By blending AI, cognitive science, and semantics, we're challenging the very definition of computational hardness. It's about rethinking how we approach problems, potentially unlocking efficiencies we haven't even imagined. The journey continues.